All right, we'll get started. Hello, everyone. Welcome to our webinar. We're going to talk about risk analysis and analytics using Safran Risk. My name is Ian Nicholson. I am VP Solutions at Emerald Associates. I work in many industries, and I work a lot in risk and also in turnarounds and sometimes risk in turnarounds. But I've worked in a number of different industries, and I'm going to be talking today about how we can apply risk analysis to various projects. Joining me is Mary Lynn Backstrom. Mary Lynn's in Edmonton. Mary Lynn is an implementation specialist with Emerald. She has many years of experience as well in many different industries. So let's just talk generally about why do we need to conduct risk analysis on our projects. Well, first of all, risk analysis helps our project teams and executives understand and manage the risks associated with their projects. It gets the project teams discussing the challenges of the project and where things are likely to go wrong. It also helps them focus on the right issues. You know, there's many things that can go wrong on a project, and what we're trying to understand here is which of those things is more likely to have an impact on the project. So things like our near critical paths that become critical paths when risk happens, or our cost estimates. Maybe we've got a lot of uncertainty in certain areas, and we want to understand, where do we need to focus our procurement efforts to make sure that we can reduce those cost risks. Now, risk analysis is a requirement of many companies' gate approval processes. Sometimes those need to be done on a regular basis to just understand where things are going on the project, and to really help us understand the dependencies between cost and schedule. So we all know that cost and schedule are related on a project. You can't have a project run late and not spend more money on it, and you can't typically accelerate a project without spending more money. But we need to understand what those dependencies look like. So at some point, we could spend all the money in the world and we're not going to save any time. Alternately, we could give up all the time in the world and we're not going to save any uh, um, money. So we just need to understand, what are those dependencies? What do they look like? So ask yourself, do you build detailed CPM schedules? Do you develop detailed cost estimates? Well, of course you do. Everybody does. And yet, the chances of us being on time and on budget are typically a lot less than the project teams would like them to be. So why is that? Well, there's a bunch of things that can cause issues when you're working on a project. Let's talk about a few of them. We do detailed CPM scheduling, but the problem is that the data is entered as finite values rather than ranges of uncertainty. So our estimate says, okay, we got 4 days of work for 3 people at $100 an hour. But sometimes the assumptions aren't correct. Things change over time. You thought you were going to be doing this work in the middle of summer, and now you've got to do the work in the middle of winter. So now it's going to take an extra day because those people have to bundle up, or they have to quit working because it's too cold, or they just lose productivity. Or maybe that $100 an hour isn't valid anymore. You did this estimate 5 years ago, and now it turns out that you're paying $125 an hour. Or maybe your crew size has changed. Maybe you go from a crew of 3, now your standard crew size is 4. So what kind of impact does that have? So all those things can change. And the problem is that those changes in scope, time, and conditions aren't typically modeled in our original deterministic schedule. We do detailed cost estimates, but sometimes there's a problem because our estimators are too optimistic or too pessimistic. The bid process encourages people to be very aggressive in their estimates to get the job. On the flip side of that, sometimes estimators have been burned too many times by people taking away their contingency. So they start hiding contingency in various places, and they end up with an overly padded estimate. Sometimes estimates are built on historical experience that isn't right, or maybe they're built on a project that doesn't scale to this project. So maybe the estimate project was larger or smaller than this project, and somebody's just scaled the costs, and it just doesn't line up the same way. So these items are all called deterministic. What's the problem with a deterministic estimate? Well, it doesn't take any uncertainties or risks into account. And uncertainties and risks can build on one another to make the project very different from what we originally intended to do, right? You intended to build this thing, through the summer months and then, be inside by the time winter came. So all the inside work could be done out of the weather. Turns out you started the job in the middle of winter and now you're not going to be inside until the spring. So all that work outside has to be done in the cold. So all of a sudden your productivity assumptions are wrong. There's a classic example where we say, there's uncertainty in everything we do. For example, the driving to work example is a classic one. We say, I don't know how long it's going to take me to drive to work on any particular day. It might be 20 minutes, it might be 30 minutes. And I do that every single day. But I'm going to build this plant that I've never built before in a greenfield site in the middle of nowhere, and I'm going to do it in 24 months. So, we need to think about, let's be realistic. Let's make sure that we can um, understand what's likely to delay and impact our project. Now, historically, the other issue that comes up is we build a cost model. So we build our cost uncertainties and we build our schedule uncertainties and risks. And at the end of the day, we have these two models that don't interact with each other. Well, as I said before, we know that cost and schedule are intrinsically linked. In fact, there's been a case study here in Alberta, where I live, um, done by the Construction Owners Association of Alberta. They look at mega projects across the province, those being projects over $1 billion. And what they found is that on average, those projects are 17% over cost and 19% over schedule. So kind of tells us that those things are related, right? And we all know that you can't, as I mentioned before, your cost and schedule are related. And if we build two separate risk models and we don't understand the dependencies between them, then the project team doesn't have the capability of trading one against the other. So what we really need is we need a probabilistic combined cost and schedule risk model. So how do we do that? Well, so we need to be able to model our costs and schedules more accurately. We need to limit financial exposure. We need reproducible results that our teams have confidence in. We need to improve the likelihood of project success. We need buy-in from our project team members. We need to make sure that we can do this on a consistent basis, which is what we talk about when we talk about maturity. So we have all of our projects doing an effective risk analysis. And ideally, we want to store everything in a common database so we can go back and look at it. Um, so the tool we're going to talk about today allows you to do all of these things, and that's Safran risk analysis. So it allows us to put our risks and uncertainties in on both our schedule and our cost model, and then it allows us to link the two together. So it allows us to build that combined model. So at the end of the day, it helps us understand our trade-offs between dates and costs. It helps us understand the key drivers and the things that are actually impacting the project so the project team can get ahead of those things and actually um, have a better likelihood of being on time and on budget. It also lets us run scenarios. So when we do our mitigation strategies, we can say, okay, what if we can get rid of this risk? What if we can mitigate that risk? What does the model look like now? Which helps us really understand if we're going to spend a bit of money to save some time, is it worth it in the end? So, we might have a risk that's going to cost us a month's delay on the project, but it's going to cost us $100,000 to mitigate that risk. Well, is a month of time on our project worth $100,000? That's the kind of analysis that the project team needs to do. Not just because you can mitigate something doesn't mean it's always cost effective to do so. And we need to understand how that impacts our model. So let's dive in and take a look. I'm going to share my screen here. All right, so you should be seeing the outputs from Safran from our schedule. So I'm going to start at the end. I'm going to talk about the outputs and I'm going to talk about how we get to those outputs. So the first thing is what I want to see as a project manager. I'm looking at this from a schedule perspective. I want to understand, first of all, what's the probability that my project is going to be on schedule? Well, Safran tells me in this particular model, and we'll go into the model in detail in a few minutes, but it's telling me that I am currently about 5% likely to be on schedule, and that's represented by this blue bar here. So this output is basically saying in the simulations, here's all the outputs that we got, and our target date to finish this particular project was the 21st of October. And the system said that in our simulations, we ran all the way out to the 7th of February. So we ran out on this project, significantly, by about what, 4 or 5 months. So every time it does a simulation, it records the outcome of that simulation in terms of a date, and it tells us, okay, here's where you're likely to end up. So it's saying I'm 5% likely to be on time. Well, what if I want a confidence level that's a little better? What if I want to look at, give me my 70% confidence level, which basically is saying in the simulation, 70% of the time I finished by a particular date. Well, Safran tells me that if that's what I want, I need to look at the 13th of March as my finish date. If I want to go to a P80 date, I need to go to the 12th of April. Now, I've got my highlighter set up to tell me that, in fact, the difference between my deterministic date and my P80 date is 174 days. So that's how much contingency I need to get from my deterministic schedule up to my P80 confidence level. So I need 174 days contingency. But Safran will also tell me on a cost basis. So my budget for this particular project was $8.4 million. Now, Safran tells me, well, you're 18% likely to be on budget. Okay. If I want to get up to a P80 confidence level on my budget, I need to get up to about $9.1 million, which is about $725,000 of contingency that I need. So at this point, I've got my, what do I need to be 80% confident in my dates? And what do I need to be 80% confident in my costs? But it's a little more sophisticated than that, because I'm not successful in my project if I'm on time but over budget. Similarly, I'm not successful in my project if I'm on budget but over time. To be successful, I need to achieve both. So this is where having the integrated cost and schedule model really pays off, because now what I can do is I can look at the combined schedule and cost. And I can see here when I look at that in Safran, this is what we call our scatter plot. And a scatter plot represents the the overall cost and schedule output for each iteration of this simulation. So I did 10,000 iterations of this, and you can see that each of these dots, if I hover on a dot here, so this one says, in this particular iteration, you finished on the 24th of January at a cost of $9.1 million, and that puts you at a JCL, a joint confidence level of 47%. So what does JCL, joint confidence level, mean? Well, that joint confidence level is the probability that we're going to be on time and on budget. What I want is I want to be at a P80 value, right? Because I said I wanted P80 schedule, P80 cost. I want an overall P80. Well, when I look at my overall, you can see that the interface line between this orange band and this red band represents P80. So the dots that are right on this line are where I was 80%, I had an 80% joint confidence level. So I was on time and on budget. So in order to achieve that, and I just hover my mouse in here, it says that at this particular dot I'm on, I would need to go out until the 6th of May at a cost of $9.3 million. Now, what's interesting about this is you'll see that that interface between the orange and the red isn't a straight line, it's a curve. So that's kind of interesting if you think about it. What that's telling me is my project team could spend a bit more money to save some time by moving this way up the curve. So over here, for example, I could finish on the 18th of April, so I'm a few weeks earlier, but the cost went from 9.1 up to $9.4 million. So I could spend a bit of money to save some time. Now, what happens though is, as you can see, that the curve starts getting steeper and steeper and steeper. because what's happening is it's getting to the point where if I spend more money, I'm really not saving any more time. And at some point it goes vertical, which basically says it doesn't matter how much money you spend. This is the earliest that the simulation is showing you're going to finish the project. Now, what if cost is more important than schedule? Well, in that case, I go the other way. So the project team can say, okay, let's choose this point over here, right? So in this case, again, I'm still at a P80 value. Um, and I've let my schedule slip out until June the 2nd, and my cost is coming in at $9.2 million. So I'm saving a little bit of money here. But what I could also do is I could move further down, let more time go, which gets me to a lower cost again. But again, the same thing eventually happens. The line goes horizontal, which means it doesn't matter how much time I give up, I'm not going to save any more money. But in between the point where it goes vertical and the point where it goes horizontal, the project team has the ability to trade off cost versus schedule. So if cost is more important, I can move to the left. If schedule is more important, if schedule is more important, I can move to the left. If cost is more important, I can move to the right. And I can decide where I want to be on that curve. And that's called the JCL necklace because you can see it's a bunch of those points on a curve. So this is great information. Now the project team says, okay, I want to be somewhere in here. They just say, okay, I need to have my 80% confidence level. This is what I'm going to choose. I'm going to choose that I'm going to be done on the 6th of May at a cost of $9.275 million. I got my contingency values for both cost and schedule. So how do we get there? So this is great information, but how do I actually build this up? So let's go back to the beginning now and talk about how we build a model in Safran. So the first thing is we'll go back and look at the tabs across the top of the screen. See this green Analyze tab here. Everything to the left of this tab is input information. Everything to the right of the tab is output information. So it's very workflow based. As a user, I just start at the left and I fill in all the boxes, and then I can run the analysis and look at the results. So first of all, we need to have a project. So I can import a project from P6. I can import a project from Microsoft Project. I can import a project from Safran Project Scheduler. Um, or I can open a project that I've previously had open. And I'm just going to open one here. Now, when I open the project, it takes me to a Gantt chart. So the first thing I obviously got to do when I want to do cost and schedule review is I need to have a cost estimate, and I need to have a schedule that I'm actually going to do my risk analysis on. So let's start with the schedule, and we'll come back and look at the cost estimate in a couple minutes. So the first thing is it opens up in this Gantt chart view, and you can see that you have a tool here that looks a lot like P6 or a lot like Microsoft Project. And because Safran Risk is built on Safran Project, you actually have a fully featured scheduling tool here. So I can make changes to it, I can group it and sort it and filter it. I can do all those kind of things that I would do in P6 or Microsoft Project. So I don't have to go back to the source system every time I want to tweak something. So if I see something I don't like and I go back to the scheduling team and say, you've got some start finish relationships in here that doesn't make a lot of sense. And they say, oh yeah, we made a mistake. Instead of them having to fix it and send you a new file, you can just agree you're going to fix it yourself and keep moving. So it saves a lot of back and forth you would otherwise have to do. I can change logic. I can do anything I need to do in this tab. Now, the system also will give me a list of schedule warnings. So it will tell me if there's a problem with any of the things that are in my particular schedule. So if there's an issue with, let's look at the things it checks for. So if there's issues with constraints in the schedule, if there's lags in the schedule, if there's missing or strange relationships, it will warn me about all of those things. So it gives me a chance to go in and fix it before I go any further. And you can spend a lot of time when you're doing risk analysis fixing the schedule. Now, um, one of my mentors used to say, when you're doing scheduling, it's garbage in, garbage out. But when you're doing risk analysis, it's garbage in, toxic waste out. So we want to make sure that we have a good, robust schedule. And so you can spend a lot of time getting your schedule properly set up for risk analysis. Um, and Safran helps you do that by identifying things that could be a problem. If I want to go take a look at a particular activity, I can click on take me there. It'll take me to that activity. I can take a look at what's going on and decide whether I need to make a change. And I'm just going to flip to a different project here. Now, once we have a robust schedule, um, then what we can do is then we can look at the risks on our project. And I'm going to come back to the cost module. There's always people who say, well, show me the cost module. That's what I care about. Don't worry, I'll get there. So let's talk about project risks. Now, for those of you who might have used Primavera risk analysis, and I've used it for 20 years, um, we always have in Primavera risk analysis, we have risks that go in the risks module, and then we have uncertainties which go directly on the activities. Now, here in Safran, they've taken that a step further and said, okay, we're going to put everything in one place. So although this tab is called project risks, this represents all risks and uncertainties on our project, all in one place. And this is just so that you can assign multiple risks and uncertainties to one activity or cost account line item um, more easily than you would be able to, or more easily than you would be able to in an older tool like PRA. So instead of going in on every single activity and having to put uncertainties in there, I can just go in here and define what all my risks are and then assign them. And I'll show you how I do that. Now, if I take a particular risk, in this case, this particular project is a UAV prototype project. So we're building an unmanned air vehicle. We've got to build the thing, we've got to test the thing before we can go to market. So we've got some risks associated with that. And one of these is that when we actually want to do our flight testing, there could we're doing it on an island that has a volcano, and there could be an ash cloud. It happens from time to time, and it would impact our testing. So in this case, we say, okay, there's a 40% probability that could occur. And here's what the impact looks like. So if it happens, it's going to potentially delay our flight schedule. Now, I've got some other ones in here as well, like we change our design specifications. Now, in this case, this one's 50% likely to occur, but it has a schedule impact and a cost impact. So any particular risk that I define can have a schedule impact, it can have a cost impact, or it can have both. Okay. Now, I can also define a pre-mitigated position for that risk or a post-mitigated position for that risk or both as well. So what's the difference? Well, the pre-mitigated position is where am I at initially? The post-mitigated position would be where am I at after I've done my mitigation work? So I can see how things get better, hopefully, after I do my mitigation strategies. Um, so we have the ability to put both in, and we have the ability to define how much those mitigation strategies are going to cost us by defining what actions we're going to take and adding schedule and or cost to get there. So if in this case we're concerned about design specifications change, maybe what we're going to do is we're going to do a more robust design review early in the process. But that design review is going to take us a month to do, and it's going to cost us $100,000. Well, we build that into the model to say, is it worth doing to get from our pre-mitigated position to our post-mitigated position? So we're going to spend a month. Are we going to save more than a month? Hopefully we are. We're going to spend a bunch of money. Hopefully we're going to save more money than we spend. So those are the kind of things that this tool will allow us to model. Now, your impacts, they can be relative or absolute. So a relative impact means it's going to increase the duration or cost by a percentage of the original value, whereas an absolute means it's going to cost us this much money. So if we get a fine for uh, releasing pollutants into the local waterway, and it's going to cost us $100,000, well, that would be an absolute number. So we have the ability to define either way. Now, once we've defined what our risks are, we can then map those risks to the activities and or cost elements. And again, as I said before, I'll come back to costs in a couple of minutes. The idea here is if I choose an activity in the schedule, I can then tell the system which risks are associated with that particular activity. And let me show you how that works. I'm going to go here to the Schedule Impact tab. So what you see here is I've got this activity, which is agree the contract, and I've said these are the risks that impact this particular activity. So we've got four of them. We've got our external communication risk, we've got our governance risk, we have just a general uncertainty, which is low at this point, and we have a procurement delay risk. Now, if any of these were to happen, actually, the sum of each of these looks like this. So what the system does is it does a little mini Monte Carlo analysis to say, hey, these risks that you've put on will end up impacting this activity, so it looks like this. So our deterministic duration is represented by that black bar, which is 10 days. And then each of these represents the sum of all of these impacts. Now, this is really good because if I put some ridiculous impact in there that suddenly pushes my 10-day activity out to being 150 days or something, I will see that immediately. And I can go back and say, wait a minute, does that make sense? So it allows me to catch any issues very quickly. Now I can just go and add another risk to this. So I could say, okay, well, if our E communication is a risk, then probably our I communication, which is internal communications, is also a risk. And I can just add it. And immediately I see the impact with this extra risk added. So you can see now that our mean has moved out a little bit, our distribution shape has changed a little bit um, as we add or remove risks. Now, um, we also can correlate risks and impacts together. So what we can do is we can say, okay, if one risk fires, is another risk also likely to fire? And we can say that the probability of occurrence is linked, the impact is linked on a schedule basis and or a cost basis. So the system allows us then to do our correlations. And I don't want to spend a lot of time on this, but just want to show you that it is there and we can correlate our probability of occurrence and our impacts if they do occur. Now let's go back and talk about the costs. So we have this cost worksheet. Now you'll notice that um, this cost worksheet allows me to put in my estimate values. It allows me to put in a base uncertainty. This is all in dollars, but I can also go in and I can define it by quantities. So I could go in and say, okay, for transportation, for example, um, it's going to cost me $120,000 per shipment to get things moved out from um, where my manufacturing site is out to my test site. So now I can put in an uncertainty there to say, well, it could be as little as a 98,000. It could be as much as 185,000. We all know what the global shipping situation is like. There's a lot of uncertainty there. And I can say, and I'm assuming I need 3 shipments. But I could also say, well, but I'm not entirely sure about that either. So I could maybe need as few as 2 or as many as 6 shipments. And then I could also put in there, well, my shipments have to be paid for in, say, euros, because all these shipping companies are European, and I'm working in US dollars. So there's a chance that my exchange rate that I'm assuming is going to be 1-to-1 actually won't turn out to be that way. So maybe it could be between 90 cents and $1.20. So again, I can build all of these uncertainties in here, and the system will take all of them into account. But it gets even better than that, because what I can also do is, remember we had those risks and we said that a risk can have a cost associated with it. Well, any of our cost line items, we can also associate risks with. So for example, if I look at my transportation, right? Let me pull this on so you can see it. So here's all the risks that I defined in my project risks tab that have a cost associated with them. So what I can do is then I can assign these, just like I did with the activities in my schedule. I can assign these risks to my cost items. So in this case, let's say that we make a change in strategic direction, um, and that's going to end up impacting the way that we do our shipping, right? So we decide, okay, yeah, we're not going to do it this way. We shipped half our stuff out here, and now we're going to do something totally different. We got to ship more stuff out, or we're going to do our testing somewhere else, or whatever it happens to be. So we can say that risk is associated with this cost line item. So I can add that in. So now what's going to happen is in my simulation, whatever probability I defined it for this occurring, when it does occur, it's going to impact this line item in my cost worksheet. Now, when I put those risks on, I will actually see, just like I did in the schedule, what does that look like for my overall cost? So in this case, I had my base uncertainty. It could go from 98.4 to $184,000. I had my quantity uncertainty. I had my exchange rate uncertainty. I had a strategic impact. So here's what my overall cost distribution looks like for transportation. So remember, I thought I was going to need three shipments at $120,000 or 122,000 or 123,000, which brings me to my deterministic value of 369. But it's saying, you know what, your cost here, your mean cost is around $540,000, and you could be looking at up to $1 million for shipping based on all of these risks. So again, it gives me a chance to preview those things before I run the model. Okay, now remember I said before, well, what we really need to do is we need to understand the how the cost and schedule work together. So let me give you an example. If I have to do some work out in the field, um, and I buy all the parts and they're all there, and then the work gets delayed, well, the parts cost isn't really going to change, right? I bought the parts, they're there, and maybe there's not even a lot of uncertainty around the cost of the parts, but now I'm getting delayed. So the tradespeople are there and they got work to do and they're getting delayed. They can't do the work. Well, they're still getting paid. So in that particular example, my installation cost, my labor cost is going to go up and it's going to be directly linked to the schedule. So if that installation activity goes late, I'm going to spend more money. But I've already bought the material, so that part of the cost is not going to change. So the beauty of the way they've built it in Safran is I can choose which of my cost line items are linked to my schedule. And let's look at an example here. I'm going to scroll down a little bit. So in this case, let's go over and look at my fabrication resources. So these are the tradespeople who are going to put this thing together for me. Okay. In that case, this is entirely labor. So what I can say is this fabrication resources cost line item is 100% linked to this fabrication activity. And the way I do that is I just go in here and I can choose from my schedule any of the activities that this is related to. Now, it doesn't have to be 100%. If I've got 50% labor and 50% materials, I can just choose to link 50% of the cost or any percent that I think is appropriate. I can also link this to multiple activities. So it will distribute that cost line item over the duration of that activity. And when the duration of the activity goes long, the cost will go up. When the duration goes short, the cost will go down. Okay, so this is the real power here because I don't have to link everything to the schedule. So in PRA, if I wanted to do an integrated cost and schedule analysis, I had to put my costs somewhere in the schedule. And the problem with that is I got all these costs that aren't schedule related and I still had to stick them in there somewhere. So I'd stick them on milestones or I'd stick them on activities that never changed or whatever I was going to do. But it was a lot of work to put that together. Now what I can do is I can say I've got a cost model where some of the items are schedule related and some of the items are not, and I can easily make that linkage. So in this case, let's think about what's going to happen here. So I've got, say, this line item here, which is my construction resources. So I've got a budget of 470,000, but there's some uncertainty on that. It could be greater or less. And I've linked that to this particular activity. So what's going to happen is when the system does the analysis, it's going to start off with the base number. Then it's going to add the uncertainty from the base distribution. Then it's going to look at the duration of this activity deterministically, in this case, 8 days, and say, okay, it's going to cost me $58,700 per day. So if this activity now takes 10 days, it's going to take 20%, it's going to take 20% more money to do the work. So the idea here is when that activity goes long, my my overall cost is going to increase on this particular activity. When it goes short, it's going to decrease on this activity. Now, if I've also got risks in there, they're going to come into play as well. So the model is going to look at what's my base uncertainty, what's my quantity distribution, what's my exchange rate, what are the risks on there, what are the activities this is related to put it all together to come up with what the final cost number is going to look like. So that means that when I actually go and run the analysis, the system is going to take all of that into consideration. Now, even when I run the analysis, the system helps me out. So that there's a couple things here that the system lets me do. The first one is that I can tell it which risks I want to include in my simulation and which ones I don't want to include in my simulation. So if I think that a risk is not going to happen, or if the project team wants to know what the model looks like without a particular risk, and that kind of what if scenario is very useful when the project team thinks that they can mitigate a risk. So can I get rid of this risk entirely? Or maybe I can just move from the pre-mitigated position to the post-mitigated position on a particular risk. So again, for those what if scenarios, I can turn them off completely or I can run them in either position. And for those of you that use Primavera risk analysis, you had to run the whole model pre-mitigated or the whole model post-mitigated, which meant that it was you ended up having to make multiple versions of the model to do this kind of what if scenarios. So here we just have to toggle a few radio buttons to go from one to the other. Other things it will let you do, it will let you use Latin hypercube sampling versus Monte Carlo analysis. I don't want to get into the technical details of that in a 1 hour webinar, but um, it allows you to use either one. It allows you to include or exclude the correlations that you've defined. So sometimes your correlations, when they fire, are having a huge impact, and to understand what that impact looks like, you can toggle them on or off. You can resource level after each iteration, which is very useful if your source schedule is also resource leveled. So if it's a turnaround schedule and you're using resource leveling in Primavera, you'll want to use resource leveling here as well. And finally, it lets us do this thing called step through. So step through allows us to see what's happening in each iteration of our schedule or cost model. It also lets us define how many iterations we want to run. Now, people generally in PRA would run a relatively low number of iterations because it was fairly slow. Whereas here, the analysis is much faster. It's just a more modern piece of software. So I typically would run 10,000 iterations or more because it happens so quickly. When I click Run the Analysis, it takes me to the Gantt chart, and as I step through, I can see how each iteration is impacting, and I can just make sure things are happening the way I expect. So if I've got some probabilistic branching in my schedule, or I've got some activities that exist sometimes and don't exist others in the schedule, I can kind of make sure things are moving the way I expect in each simulation. And similarly, I can go to the cost model. If I scroll all the way to the end, I've got my iteration value, and I can step through that as well. So I can see how things are changing. Let me pick the second line so you can actually see the top line. Move this out of the way. Come on, show up. I guess I have to be on it to see it. But anyways, as I scroll through, you can see it's now 8.5 million. Then it's 8.1 million. So again, you can see how things are changing with each iteration, depending on all of those risks and uncertainties and everything that I've defined in the cost model. And of course, the schedule impact as well. So while I'm clicking through, I can just make sure everything is kind of doing what I expect it to do. If I see anything I don't like, I can just hit cancel and go back and fix it. Like if one of my cost line items isn't changing, or one of my activities in the schedule isn't moving the way I think it should, I can just abort and go back and figure out what's going on. But if I'm happy, then I can just hit complete. And you can see it runs our 10,000 iterations very quickly. And then it takes me to that distribution graph that we saw at the beginning. So let's look a little bit more into where these come from. Let's go back to the schedule one, and I'll talk a little bit about what this information is telling me. So first of all, the bars represent a date that we came up with on our when we ran our analysis, and then the vertical or y-axis represents how many times in our 10,000 iterations that particular date came up. So in this case, we can see here that our date of December the 15th came up quite a bit. It came up around, I don't know, what is that, say 1,750 times in our analysis out of our 10,000 iterations. So that's what the bars represent. And then this line that comes up here represents the overall cumulative value. So that's why we can say our P80 result is the 13th of April, because that's saying in 80% of the simulations, we finished on or before this particular date. So if we want an 80% confidence in our date, we need to use this date as opposed to our deterministic date, which was back in October. Now it does the same thing for cost. So it will show me exactly the same information, but on a cost basis. Now, if I want to drill in, I can do so. So if I want to choose a particular activity in the schedule or a particular cost line item, I can go and highlight that and see the information specifically for that particular activity. So if I've got some kind of milestone that I really care about, I don't necessarily have to look at the overall schedule. I can just look at some intermediate milestone, like when do I turn this over to the owner? And I can even do it where I can make that a focus activity. So instead of having to go all the way through and drill down and find it each time, I can define any particular activity as a focus activity, which means it's easy for me to get to. Now, it's not a big deal in this particular list where I've only got like 50 activities in here, but if you've got 10,000 activities, scrolling through here to find stuff can be a bit of a chore. So I can make those key dates or those key events as focus costs or focus activities. Now, the system will also tell me what's driving this thing. So, on a cost or schedule basis, again, what are the risks that are having the biggest impact? So, we call this a tornado plot for obvious reasons. It kind of looks like a tornado. And this helps the project team understand what are the risks that are having the biggest impact on our overall project. In this case, it says contractor liquidation is having the largest impact with a correlation of zero point 0.6. Now, when I go to see the project team and I say that, I say, yeah, this is at zero point 0.6 as opposed to testing overrun, which is at zero point 0.4. They always say, well, what's the difference between zero point 0.6 and zero point 0.4? And my answer is 0 0.2, which satisfies absolutely nobody. So Safran even goes a step further, and it lets us go to the sensitivity analysis. And the sensitivity analysis allows us to go in and say to the project team, hey, how much of an impact is this particular risk having in terms of days on the project? So let me just check my options here. Yeah, they're set properly. So what I'm going to do is say, okay, I'm interested at P80, calculate the impacts. And what it does is it actually goes through and runs the analysis by turning off each risk in turn. So the idea here is we call this analysis by exclusion. So we want to know how big an impact a risk is actually having. The only way to know that in terms of days is to turn it on, run the model, turn it off, and rerun the model. And that will tell us exactly how many days at a particular confidence level that particular risk is impacting us. So it's basically running through and doing all this analysis for me. And what it tells me is contractor liquidation, it actually has an impact of 37 days. Whereas poor flying conditions has an impact of 36 days, testing overrun has an impact of 25 days at P80 confidence level. So if P80 is what everybody's working to on our project, I can say to the project team, if you can get rid of this risk, you can save 37 days out of that 187 days, I think it was, that we said we needed for contingency. So this is much more useful to the project team than going back over here and saying, well, it's 0 0.6, which means nothing to anybody. Okay. Now, in fairness, what is important between these is not the 0.2, it's the relative impact. So zero point 0.6 is 50% more than zero point 0.4, which is actually what would be my real answer, not the difference is zero point 0.2. But the fact that we have the sensitivity analysis in Safran makes it much easier to explain to the project team, this is the impact of this risk in numbers that you can understand, and actually say 37 days is a lot of days in our schedule. That's almost 2 months. Because remember, those are working days. Now, I can do the same thing on a cost basis, right? I can look at this and say, my design specifications change, again at P80, is impacting my project by $159,000, right? So contractor liquidation is $135,000. So again, from a cost and schedule perspective, I can see very quickly how big an impact these things are having. So very useful. And in PRA, I had clients who would do this manually. They would actually go in and manually um, uh, turn these risks on and off and look at the results, which was a real chore. And it could take a week to do, whereas you can do it in a couple of minutes in Safran. So finally, we get back to our scatter plot where we started again. And based on all of that information that we've put in, we can go to the project team and say, hey, here's where we think your contingency needs to be. If you want a P80 joint confidence level, you can pick anywhere on this curve for your contingency. If you want a P70, you'd be on this curve. And you can define where those curves are as well, by the way. You don't necessarily have to use P80, P70, you can use whatever you want. Now, if I leave things the way they are, if I don't put any contingency at all in, the system's saying your overall probability of being on time and on budget with your deterministic values is 2%. Okay. So we had a 5% chance of being on schedule. We had an 18% chance of being on budget, but overall we have a 2% chance of achieving both. All right. And the way that comes up is it's basically chosen that point and said, what percentage of our 10,000 hits were inside that box? And in this case, it's saying 2% of the time you were on time and on budget. So it's not looking good. However, now we can work with it. We can say, okay, here's what we think our contingency needs to be. Let's go back and do some mitigation work. Let's understand how this model works. Let's decide where we're going to spend a bit of money to save a lot of money. And those are the kind of answers that you can give your project team with Safran Risk. Okay, so I'm going to stop sharing my screen and go back to my slides. So Safran is used by companies all over the world. They've been very successful with energy companies, with Department of Energy groups in the United States. People like Strategic Petroleum Reserve, a lot of cleanup sites, those kind of things are all using this tool. So a lot of use of the tool in all over the world. Um, my company, Emerald Associates, can help you get up and running with Safran. So one of the big challenges that people have is they buy this very sophisticated piece of software and then they struggle with how can they get it working. So we provide assistance. We can help you with your first couple of risk analyses. We do training, so we can actually get you trained on the tool and how to use the tool so it's less intimidating and help get your project team up to speed as quickly as possible. We do Primavera work. Obviously, we do a lot of Safran work. We do implementation and training as well. So at this point, I'd like to open it up to any questions that anybody might have. There's a question section in the on the screen. If you'd just like to put your questions in there, I'd be happy to answer them and to perhaps show them within the tool. Okay, I'm not seeing any questions so far, so I'll leave it open for a moment. In the meantime, I'll put up some contact information. Um, so here's my contact information. Also for people overseas, we have a representative, Donna, in the Philippines, and there's her contact information as well, in case anybody would like to reach out to her if she's closer to your time zone than I am. Um, and we're available to answer any questions or to help you get started with Safran. Okay, so there's a question up here. Is the software available for training purposes? So that's a two-part question. So for training purposes, when you take training, you definitely get the software. But if you want to download the software, you can get a trial off Safran's website, a 30-day trial, and it will let you go in and work with the software and and get started with it. If you if you struggle with it, you can reach out to us. I always tell people, after working with Primavera risk analysis for um, close to 20 years, when I first tried using Safran about 5 years ago, I kind of struggled with it because things are a little different than PRA. And spending an hour with one of the executives at Safran really helped me um, get pointed in the right direction, in which case it became much easier for me to work with. Um, Somebody's asked here about my WhatsApp number. I can provide that after the session if you want to have a call. Um, I won't provide it here, but I can provide it afterwards. Um, are there any other questions that I can answer? Okay, the question is, how do we convince our boss that this is the way to go for risk management? So actually, it's interesting. If you were already using Primavera risk analysis, I wrote a series of blog articles a few years ago for Safran. They're on Safran's website now. You can actually go and find them there. That basically said, why should I move from Primavera risk analysis to Safran? And I outlined the reasons. Things like it's much more modern software. Um, Primavera risk analysis hasn't been updated since 2013, so it's 10 years since they actually did a major release of the software, and it's 8 years since they did even a patch. It's amazing that it still works. Um, but it's on a more modern database. It allows you to do integrated cost and schedule risk analysis, which groups like AACE and PMI say is best practice. So there's a whole bunch of that information in my blog articles. Um, and So the other thing about it, there's a comment here: risk is more than a list. Absolutely. We talk about the risk maturity model. Um, if you're dealing with a group that's never even discussed risk or never documented what their risks are in a project, there's a lot of work you need to do before you can build your first risk model. You need to work with your project team to actually develop a risk register to start tracking that. And actually, Safran has a tool called Safran Risk Manager, which is a great tool for that kind of thing. It actually lets the project team collaborate on the risks. You can assign risks, you can track what's going on with those risks, and eventually, when you need to, you can port that to Safran Risk to actually run the actual model. So for people who are um, who are getting into that and have a bit large organization or even just a large project, Safran Risk Manager is a great tool for that. Um, yeah, so a couple of other comments here. Somebody said that they've been using Primavera Risk, aka PertMaster, for a long time, um, uh, but yeah, never realized the system's this good. Yeah, I mean, essentially, the guys who actually developed PertMaster before Oracle/Primavera purchased it were heavily involved in this development of this tool, and their guiding principle was, okay, if we were starting again today, knowing what we know 20 years later, what would we do differently? And they applied all of those lessons into this tool. So this is a great tool um, in terms of um, you know ease of use and quality results. So it's just a fantastic tool. There's a question: when's our next risk training? And Shannon has actually posted that. We were going to. Our next one coming up is April 17th to 20th, and there's a link there in the chat um, of when that next training is. If you have a large group to be trained, we can do custom training as well. So If you have an organization with 5 or 6 people that need to be trained, we can do custom training as well. All right, I think we're just about out of time. So, and I don't see any more questions posted. So if you do think of any questions, feel free to reach out to me. Again, my email address is there. Um, and if you have any questions, reach out to me. If not, we'll wrap things up. There's a great resource also on Safran's website, I should mention, there's a lot of information with a lot of white papers by a lot of very talented people about why you should do integrated cost and schedule risk analysis, why Safran's a good choice compared to some of the competition out there. And there's some great project profiles as well, so you can kind of learn about how other people are using Safran. So I'd encourage you to go and take a look. And as I said, if you want the trial version, just go to Safran's website, and you can request a trial there. You give them your email address, and they'll let you download the trial. All right, with that, we can end the session. Thank you everyone for joining us today. I hope you found it informative, and hope to hear from you soon.